Hey guys, so I'm going to go through two problems with you. So you have two complete examples, one with a leading coefficient of 1 and one with a leading coefficient of not 1, of using the rational root theorem for your own reference. So for the first question, obviously you can see we have this leading coefficient of 1, and we have, so that would be our Q value. And we have a 72, which is going to be our p-value. So the first thing you always want to do is find your possible roots. So in order to use the rational root theorem, so if the directions say use the rational root theorem, you have to show me that you are using the p and q to find your rational roots. Remember, it is always plus and minus, and it is factors of the constant divided by factors of your leading coefficient. So in this case, we're going to go through and list all of these factors. So I'm going to start with 1. Obviously, factors of 1 is just 1. And now up top, again, it's up to you how you come up with them. I think in pairs. That's just how my brain works. So I would do 72 and 1. Then I would try 2 in it, and you get 2 and 36. Then I would try 3. It is 3 and 24. You could try 4, and it's going to be 4 and 18. You could try dividing by 5. It's not going to work. You could divide by 6. So it's 6 and 12. And again, you can keep testing it, and you'll find your last pair would be 8 and 9. Okay, so these are all of your factors of 72. Thankfully, they all only have to be divided by 1. So our possible roots are plus and minus each of those numbers. Okay, again, since they're all dividing by the root or by the factors of 1, it's just 1, they're all just themselves. Okay. All right, so now we have this long list, and we don't really want to have to test all of them. We want to figure out, well, where are ones I can try right away? So the second thing you're going to do is you're going to use a graph. So you're going to open up Desmos, or if you have a graphing calculator, you're going to use that. And you're going to put it into your graphing calculator. So I'm going to slide in my Desmos. Here's the first one. And I can see from my graph, here are my zeros. So I have a -1, an 8, and a 9, all shown from my graph. So I'm going to make note of that on my paper here. So from the graph, I got these values, -1, 8, and 9. You only want to use whole numbers. So if I had any decimals, obviously I can't use them, but I do then have to show my synthetic division. Okay, so that's your next step, because the whole goal is to factor this to prove algebraically what my solutions are. So I know 3 of them, but I don't know if that's all of them. So I have to do the work to check it out. So we take one of those. Doesn't matter if you choose -1, 8, or 9, but you got to choose one of them. I just tend to go in order. So I'm going to choose -1. And you're going to go through your synthetic division. Now, the reason we have to do synthetic division is because I don't know how to factor that original problem as is, right? If I tried grouping, I'm not going to get 2 groups that are identical. So I can't factor it. So using synthetic division, the goal is to get a factor or a remainder of 0 that tells me it's a factor. So we drop down the 1 and we go through our synthetic division. Okay, so multiply, then add down, multiply, add down, multiply. There we go. Good. So now I know I got this part that works. I know that the -1 here comes from a factor of x plus 1, or it's the opposite. I know that these coefficients, or these numbers, are coefficients of a new polynomial. And then I want to factor that completely. Well, factors of 72 that add to a -17, I can easily factor that, no problem. That is a -8 and a -9. And then from here, we can finish solving them. Again, we already know the solution to x plus 1 You know that's your -1. Here is our +8 we saw. And then lastly, our +9. So we were able to prove algebraically the three solutions that we saw on the graph are indeed the factors of and solutions to that original polynomial. Okay, so again, first thing when it says find the rational roots, factors of your constant over the factors of your leading coefficient. When it's 1, it's easy. We know they're all just the factors of your constant at that point. When it's not 1, we got a little bit of extra work involved, but our graphing, our Desmos, is going to help us out extremely beneficial in this. Okay, so I'm going to clear this out. We're going to do the second one. So you can, again, have an example of what happens when we have a non-1 as our leading coefficient. So let's zoom this over. Here we go. Same process. We got to find our P's and Q's. So our first thing is our constant, your P value. So that's 24. And then our Q value is our leading coefficient. So that is 2 in this case. All right, so our possible roots. We got plus or minus the factors of 24. And you don't want to use your signs. You want to use them as just the numbers, because that plus or minus in front takes care of that. Okay, so you don't want to write -24 there. Okay, factors of 2, easy, 1 and 2. I'd start with the bottom just because they're quick. Factors of 24, so 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are my factors. So when I start writing my possible roots, now I'm going to do 1 over 1. That's 1. 1 over 2. So we got a half. 24 over 1. That's 24. 24 over 2. Well, that's 12. So you can either write them all out and then reduce them later, or you can reduce them as you're writing them. It's completely up to you. So I'm just going to write them all out as a fraction so you can see where they came from. I don't know, I wrote 8 over 1. I mean, you could, it's not wrong. Okay. And then again, when I look back at these, well, 24 over 2, like, so that's 12. 2 over 2 is 1. 12 over 2 is 6. 3 over 2, I can't change. 8 over 2 is 4. 4 over 2 is 2. 6 over 2 is 3. So some of those numbers already appeared, so I didn't have to write them twice, actually. But they are part of the roots, and you can see where they came from. All right, so again, we're going to swing in Desmos. Here we go. So there's my graph right here, or my equation. And when I look at it, I got a -4, a -1/2, and a 6. So I have a decimal in this case. We only want to use or deal with our whole numbers. We can't do synthetic division with fractions. So when I write down where I got my information from, okay, so from the graph, we got -4, 6, and then I write my decimal last because I can't do anything with it, but I do have to check to see, hopefully, when I get through my factoring and my synthetic division, I get something that leads me to have a -1/2 as an answer. Okay, so we're going to do our synthetic division. I'm going to start with -4. All right, again, you could have started with 6. It does not matter. You just cannot use the decimal. So we write down all of my coefficients. Again, remember, if you are missing a term, you do need to put a 0 as a placeholder. The goal is to get a 0 in our remainder, so hopefully that happens. So let's see. Drop down the 2. -4 times 2 is -8. That's -11. Multiply, there's 44. Add down, it's -6. Positive 24, 0. Perfect. Okay, again, -4 comes from the parentheses x plus 4. 2, -11, -6 become my new my new coefficients, and we decrease an exponent from there. Now, at this point, you can choose to factor that again. It does factor pretty easily, but I do want to show you how we can do a second round. So if I don't know how to factor this, say I'm left with something that's still too big for me, something I'm struggling with, try to figuring out factors, do a second round of synthetic division. I had another value I can use. I've already used -4, but if I try 6, that can help me out. I know it's a 0. I know it's a root. So I'm going to do a second round of synthetic division. Now the thing is, with your second round, you're using your polynomial you need to factor smaller. So I want to use the last answer I got, the 2, -11, -6. Again, the goal, hopefully, we get a 0. So let's repeat it. Drop down to 2. 6 times 2 is 12. Add it is 1. 6 times 1 is 6. There's my 0. Perfect. So far, I have an x plus 4 from the first one. That's this. I have an x minus 6. That's where this one comes from. And now the 2 and the 1, they are 2x minus 1. It's a new equation. So I was able to factor that polynomial into x minus 6 and 2x minus 1. You could have done that on your own. That's fine. But if it's a struggle for factoring, you can do it this way now to help you get to those points. And again, from here, I can solve them. X plus 4 is 0. There's my -4. X minus 6 is 0. There's my positive 6. And then the 2x minus 1 equals 0. So we get 2x equals 1. And then divide. There is my 1/2 that I saw. Oh, hold on. My bad. Sorry, this would be 2x plus 1. That's a positive one there. See, and this is how using the graph helps you out. I know I should have had a -1/2 there because of this solution. And again, there's my 3 answers I saw. The reason we have to show all this is so we can show it mathematically. And in the case that, what if we have an imaginary solution? We do have to work our way through it to make sure we're not missing any of our roots. Okay. But again, I saw this from my graph, -4, 6, and then -1/2. All were proven in my algebraic work using my synthetic division, doing a double dose of it. Again, you could have also factored that by hand. Either way, you do get to a point that shows all of our roots. Okay, hopefully it clears this up for you guys.